Good morning. Please make sure you join on time. Please tell your friends as well. I'll wait for another 1 or 2 minutes and then I'll start off. Okay, I'll start off. So last class we studied about what is pH, what are the different theories behind calling any substance as an acid or a base. Then we moved on to how do we what are the different what do you mean by pH, how pH and pOH are related with each other. Then we studied about what are different methods of measurement of pH, right? So that was calorimetric method and electrometric method. Moving on to next, buffers. Before I start with the buffers, I would like to tell you next class we will be having a unit test. Okay, next class we'll have unit test on surface tension and interfacial tension. Clear? So all of you are supposed to read and come, since the notes have already been circulated and have given sufficient time. So we shall have a unit test on the same. Clear? So it could be MCQs type or it could be quiz type, anything. Okay, get prepared for the same and come for the next class. Okay, we'll start with the buffers. Any idea what do you mean by buffers? What do you mean by buffers? Anyone? And please, I expect you to interact. Whatever you know, I expect you to tell. Yes, please.
Buffers are something which may speed up or slow down the process.
Which may speed up or slow down the process of what?
Or slow down.
Ma'am, I will tell.
Please tell your names and tell. No, the person who answered was
Ma'am Kuber, ma'am.
okay. Next, yes, Nayanpriya. Go ahead.
Ma'am, buffers are the substances which resist the change in pH when that acid and or acids or base are added, ma'am.
Okay, right. Then anybody else? No? Okay. As Nayanpriya said rightly, so these are mixture of acid or bases. Okay, so these are mixture of acid or bases which will help in preventing the change in pH if you are adding any acid or base. Okay, say now I'm having a solution. Okay, I'm having a solution. First I will just, so buffers are compounds or mixture of compounds that by their presence in the solution resist change in pH upon addition of small amount of acid or alkali, that is the base. Okay, so in general this buffers, what happens is that these are substances. Say now you have a solution of HCl. Okay, HCl is an acid, right? So you have HCl in it. So now what happens if I'm adding a base like sodium hydroxide to it? Say now assume that pH of the HCl solution whatever I was having was 1. Okay, the pH of a solution, HCl solution in the container is 1. Now I'm adding it had 100 ml of HCl in it. Say now I'm adding 10 ml of sodium hydroxide to this particular solution. I'm repeating. Assume that I'm having a container. In the container I'm having 100 ml of HCl whose pH is 1. Okay. Now I'm adding NaOH, which is a base. So what would happen to the pH of the solution now? Anybody? It was 1. After I'm adding 10 ml of NaOH, what would happen to pH?
The pH would have increased, ma'am.
Right, the pH would have increased from 1 to something. So it could be 2 or it could be 1.5, right? So now you observe that there is a change in pH. So say now to 100 ml of HCl, same instant, I am adding 50 ml of NaOH. Okay, so total solution is 150 ml now. 100 ml of HCl is there. To this HCl solution, I'm adding 50 ml of NaOH solution. Now, how much changes do you expect in pH now? Will that remain the same? It was earlier the pH was 1 of HCl. After adding 50 ml of NaOH, what would happen to pH? What would happen to pH? What is this, Prajwal? Hmm. Yes. What would happen to pH? Anyone? 200 ml of HCl, which had a pH of 1. I'm adding 50 ml of NaOH. What would happen to pH now? Am I audible?
Slightly decreases.
Slightly?
Decreases.
Decrease in what?
Decreases in
Ma'am, your
pH.
body, your
Sorry,
No, ma'am, pH will not decrease.
pH will decrease or pH will increase? Okay, just tell me acidity increases or
Increases.
basicity increases,
Basicity increases.
right? So thereby from the pH 1, it will increase the pH to maybe 4 or something, right? So the pH would increase to 4 or 5, right? So now what do these buffer do is that, as I told an example, when an acid I was having, I added base to it. So there was change in pH. So buffers are the agents which will prevent such change in pH. Am I clear? Buffers are the agents which will prevent the change in pH what we observe now. As I told, HCl was there with pH 1 and I added NaOH wherein the pH got increased to maybe 4. So that changes from 1 to 4. If at all, if it should not happen, I should add substance known as buffer. So buffers are the one which will resist the change in pH that would happen if I'm adding some acid or base to any solution. Is it clear? Anybody has any doubt? So buffers are the agents or the substance or the compounds which will prevent the change in pH. Okay, if we are adding into any solution, okay, on adding acid or bases to any solution, whatever changes would happen in like increase in acidity or increase in basicity, that can be prevented by addition of substance known as buffers. Clear? So chemically these are mixture of weak acid and its base. Anybody has any doubt, or those who didn't understand what do you mean by buffer? Okay, the same example, whatever I was giving, the HCl system, okay, to that I added NaOH, right? So if at all in the system of 100 ml of HCl, if I had already added a buffer to it, then on adding base to it, that is on adding NaOH, still the pH would remain as 1. Okay, so how is it possible? It is because of the presence of buffers. At least now it would be clear. So buffers will prevent change in pH. What would happen if we add any acid or base to any system? That is prevented by these buffers. So what chemically these buffers are? It's a combination of weak acid and its conjugate base. Okay, that is salts or a weak base and its conjugate acid. So such we call it as buffer. For example, acetic acid is a weak acid and sodium acetate is its salt. Okay, so acid and its conjugate base or its salt. Okay, so weak base and its conjugate acid acts as a buffer, the combination. Clear? Then we come across a term known as buffer action. What do you mean by buffer action? Is that the ability of certain solution to resist change in pH upon addition of acid or base is known as buffer action. So the ability of any buffer to resist the change in pH is known as buffer action. You come across another term, we'll be learning it in next. So buffer action is the one. So what is the ability of buffer to change the resist or change the in pH after addition of an acid or base? We are going to call it as buffer action. Is it clear? So for example, if to a solution of sodium chloride, a small amount of strong acid is added, the pH is altered, right? Sodium chloride to sodium chloride, we are just introducing an acid, so or a base, then we expect the pH to alter. Such a system has no buffer action. Okay, if 1 ml of 1 normal NaOH is added, pH raises to 11. If 1 ml of 1 normal HCl is added, the pH is lowered by 3. So these solutions do not have any buffer with them, hence they will not resist any change in pH. On addition of an acid or a base, obviously there will be change in the pH. Is it clear? So consider a weak acid like acetic acid and its salt. Till here anybody has any doubt? What is buffer? What is buffer action? What is chemically a buffer? What is a system without buffer? Understood? Okay. So moving on to next. Consider a weak acid like acetic acid and its salt like sodium acetate. Okay. So this sodium acetate, which is a salt, it will divide completely or it will dissociate completely because it's a salt, it will dissociate completely, right? So weak acid, acetic acid is a weak acid. So in general, weak acid is the one which will partially dissociate. So acetic acid dissociates very slightly in solution. So it is a, what do you call such reaction? This is forward reaction, this is backward reaction. Okay, so this is both things will be happening at once. So this is an acetic acid. Acetic acid will be giving out acetate ion and H plus ion. Again, this will combine and keep giving acetic acid. Okay, then sodium acetate. Actually, it's only a single. Do not consider this. It's only a single arrow. What you are able to find. Okay, so sodium acetate is a strong salt, okay, which will dissociate completely. It's only single arrow, which will dissociate completely into acetate ion and sodium ion. Same thing is written. This is a single step reaction. This is nothing but it's a partial reaction wherein acetic acid keeps slowly forming acetate ion and H plus ion. It's not a complete reaction. Its dissociation is very slow. Please, who is this? This name
Ma'am,
is
this some Shakira, ma'am. He's not. Then please remove him, ma'am. He's someone who is not known, ma'am.
who is that? Okay. So in general, this dissociates completely, unlike acetic acid. So this dissociates completely into CH3COO minus, that is acetate ion and sodium ion. Now assume that you are having a beaker. Okay, assume that you are having a beaker. Inside beaker, I'm just going to take. Do not follow these words. Whatever I'm telling, please listen to it. So in this beaker, I'm just going to add acetic acid and sodium acetate. I'll repeat. I'm having a beaker. In the beaker, I'm introducing acetic acid and sodium acetate, these two mixture. Okay. So now this will partially dissociate into CH3COO minus ion and H plus ion, and this will completely dissociate into acetate ion and Na plus ion. Okay. So now tell me, anyone, what and all would be present in this particular beaker? I'm adding acetic acid and sodium acetate. So in total, what and all ions would be present, or ions or complete whole compound would be present in this particular beaker? Anyone? Are you getting? Okay, let me only answer because it's killing time. So in general, if I'm adding sodium acetate and acetic acid, since acetic acid partially dissociates, so I have acetate ion and H plus ion. Okay, and since sodium acetate dissociates completely, I'm having acetate ion and sodium ion. So in this particular beaker, I'll be having acetic acid because it's partially dissociating. So I'll have acetic acid, acetate ion and H plus ion from acetic acid, and I'll be having acetate ion and sodium, which is from this. So we'll not have this. Sodium acetate will not have in the beaker because it has completely dissociated to give its ions. But I'll be having acetic acid because it keeps on dissociating slowly. So you have acetic acid, acetate ion from both the reaction, H plus ion and sodium ion. Am I clear? Anybody has any doubt? Understood? Am I audible? Please answer. Okay. So now in this mixture, we'll be having sodium ion, acetic acid, acetate ion, which is obtained from these two. Okay. So just assume that we are introducing a strong acid. Okay. We are introducing a strong acid which is added to the mixture. What happens is that on adding any strong acid, it will indirectly supply the H plus ions. Okay. Whatever H plus ions which is given by the strong acid, if at all if buffer is present, how these two mixture acts as a buffer, I'm explaining. So if an acid is added which will give H plus ion to this particular mixture, this H plus which is given by an acid is being taken up by the acetate ion which are present. Okay, whatever H plus ion which is being given by the acid is taken up immediately by this acetate ion. What happens now? H plus and CH3COO minus, they combine together to form what? To form acetic acid. So this acetic acid is again slightly soluble. So thereby what happens? H plus ion is combined with acetate ion to give acetic acid. This acetic acid is a weak acid which will slowly dissociate. Therefore, you do not find much change in the pH. Since the added H plus ions are neutralized by the acetate ion present in the mixture, there is very light change in the pH that would take place. Is it clear? In the mixture, didn't understand? Please speak up.
Understood, ma'am.
Understood? Okay. So this was in the case if we add H plus ions, which is taken by the acetate ion to neutralize it to form acetic acid. Acetic acid being a weak acid, again it slowly dissociates. So there is no much changes in pH. Clear? This is when we add H plus ion or indirectly an acid whenever we are adding. So what would happen if we are adding a base? So when we say base, indirectly what we are introducing? We are introducing OH minus ions. If at all, if a base is being introduced, what happens is that whatever acetic acid is present in the solution, that will be taken up by the, OH minus ions will be taken up by the acetic acid which would be present in the solution. So on combination, what does it give again? Acetate ion and water. Okay, this acetic acid on reacting with the base, it will give acetate ion and H2O. So because it's acetate ion, again there is a very slight change in the pH that would take place. Hence, a mixture of weak acid and its salt always acts like a buffer. Is it clear? Are you understanding? This was in a
Yes.
case where we
Yes.
considered a weak acid and its salt. Please let me know anybody who has not understood. And if you want, I can repeat. So where did this acetic acid come from? This acetic acid is the acid whatever we are considering. How does it exist the same acetic acid only? Because it's a weak acid, it will partially dissociate, right? So that means still there would be some amount of acetic acid without dissociation. So whatever amount is present, that will react with the OH minus ion, which is obtained whenever we add any base. Okay, it is not a strong acid. That is why you'll have, it's a weak acid. Therefore, you'll still have some amount of acetic acid unreacted. That will combine with the hydroxyl ion, which is given by the base. Okay, so consider similarly, whatever we considered was a mixture of weak acid and its salt. Similarly, consider a mixture of weak base and its salt. Like for example, ammonium hydroxide and its salt, which is ammonium chloride. Always salt will dissociate completely, and any weak acid or a weak base will always dissociate partially. So consider a mixture of bases now. A weak base like ammonium hydroxide dissociates into ammonium ion and hydroxyl ion, and ammonium chloride, which is a salt, which will dissociate completely into ammonium ion and chloride ion. So again, consider the same. Imagine a beaker. In a beaker, we are going to add these two, ammonium hydroxide and ammonium chloride. So what do we have here? We'll be having ammonium hydroxide, ammonium ion from both, and hydroxyl ion and chloride ion. We will not have ammonium chloride because it dissociates completely. But we will be having ammonium hydroxide because it slowly dissociates, right? That is why we'll be having ammonium hydroxide, ammonium ion from both the reaction, and hydroxyl ion and chloride ion. Clear? So now to this mixture, if we are adding an acid, okay, if we are adding an acid, what happens is that indirectly we are introducing H plus ions to it. Whatever H plus ions we are introducing to this particular mixture is being taken up by the ammonium hydroxide. Okay, because it ammonium hydroxide, because it has affinity towards H plus ions. So H plus ions reacts with ammonium hydroxide to give ammonium ion and H2. Again, since ammonium ion concentration was already there in the mixture, there's just increase in that. Again, it is forming a partially dissociating ions. That is why there will be very slow change in the pH and not much change in pH. Okay, there's no immediate change. As in case I gave an example of HCl and NaOH, because both were strong acid and strong base, immediately you observe the change in pH. Where in this case, since it's forming a partially partially dissociating compound, it will dissociate slowly, wherein the pH is not affecting to greater extent. Very slowly it dissociates, which has been taken up by the others. That is why the whatever change in pH you are expecting, that will not happen. Okay, so instead of an acid, if we are introducing a base, indirectly we are introducing hydroxyl ion. This hydroxyl ion is being neutralized by the ammonium ions, which is being formed in both the reactions. Like OH minus ion is being taken up by the NH4 minus, which will form ammonium hydroxide. Again, ammonium hydroxide is partially dissociating. It slowly starts dissociating. Okay, so thus there is a very slight change in the pH. Hence, the mixture of weak base and conjugate salt acts as a basic buffer. Is it clear? Anybody has any doubt or who has not understood? This is how buffers, that is a mixture of weak acid and its salt or weak base and its salt, acts like a buffer. That is buffers which will prevent small change in pH on adding acid or a base. Are you understanding? Is there any doubt?
Understood, ma'am.
No doubt.
Okay, this is very, very important. You can mark down. This is very important for 10 marks. Okay, like what do you mean by buffer? And next, whatever we are going to study, that is, there is something known as buffer equation, or in general, it is known as Henderson and Hasselbalch equation. Okay, buffer equation is also same. It's also known as Henderson and Hasselbalch equation. Very, very important for 10 marks and very easy if you understand the concept. Clear? So if you have understood till now, this becomes very easy to understand. I hope you people have understood. I'll assume it. Anybody who has not understood, please ask. Only 2 words I got. Only 2 people answered that they have understood. Others doesn't mean others have understood. So anybody who has not followed.
Yes, ma'am. Understood.
Okay. So moving on to next, buffer equation, or what we call it as Henderson and Hasselbalch equation. So there is a specific equation for acid separate and base separate. Okay. So the pH of a buffer solution and change in pH depends upon addition of an acid or a base and can be calculated based on buffer equation. So this expression considered the effect of salt on the ionization of a weak acid or a base when the salt and the base or acid has an ion in common. Say now, in both the examples, there was some ion in common between an acid and the salt, or a base and the salt. Okay, so this is base and the salt. Amongst these two, there is a common ion in general. So what was the common ion? It was ammonium ion. If you consider the same in an acid, so here there was a common ion between both two, which was acetate ion. So in general, whenever we talk about this Henderson-Hasselbalch equation, it is considered, it considers the effect of salt on the ionization of a weak acid or a base when the salt and the base or the acid, whatever we are considering, has an ion in common. It's the same thing whatever we talked that time, right? So what is the effect of salt on ionization of an acid or a base when the salt and the acid or the base, whatever we are considering, has an ion in common? Okay, so that we call it as common ion effect. Okay, so common ion effect and the buffer equation of a weak acid and the salt, if we consider. So weak acid, if we consider the same acetic acid and sodium acetate, what is the effect of addition of sodium acetate into acetic acid? Or what would happen if at all if we are considering a beaker with acetic acid when we add salt like sodium acetate? How does sodium acetate affect the dissociation of acetic acid? So acetic acid, as it is, you know, it's a weak acid. What happens if we add a strong acid to it? We know what happens. So now what I'm telling is, you're having acetic acid in a beaker. We are introducing sodium acetate, which is a salt, which will completely dissociate. So this particular, what is the effect of this salt on to dissociation of acetic acid? One more point is that whenever both of them have a common ion with them. So the common ion among sodium acetate and acetic acid is acetate ion. So in general, both of them have acetate ion in common, right? So we know that acetic acid, it's a weak acid, so it will dissociate slightly as given here, right? H2O plus CH3COOH, it gives CH3COO minus and H3O plus. Just apply law of mass action, which is Ka is equal to H3O minus concentration of these two divided by concentration of the reactant. So when sodium acetate is added to the acetic acid, so this was much before addition of sodium acetate salt. Now to this particular solution, we added sodium acetate. So now this sodium acetate is a strong salt, or in general a salt will dissociate completely. So this salt will dissociate completely into CH3COO minus and Na plus. So now what happens to a system or a beaker? Consider this as a system containing ammonium ion, acetate ion, acetic acid and H3O plus. Only three ions are present. So to this particular system, when I'm introducing acetic sodium acetate, what I'm introducing indirectly? Indirectly, I'm introducing acetate ion and sodium ion as well. Because